Okay, so the next thing that we have here is exercise 2.1, and you want to find the principal values of the following functions. So let's remember that we are looking for the principal values of the following. So suppose that you want to find the sine inverse of negative 1 by 2, right? So I'm going to explain these using probably the unit circle, and also give you some solution as well based on some other solutions. So let me get my solutions. Okay, so the way that I would solve this problem, I want to find the sine inverse of negative 1 by 2. The way that I would naturally solve this problem is that I would, first of all, I would write this as, for example, the sine inverse of negative 1 by 2 is equal to some value like y, and it's going to be some angle, right? Now, so what this means is that this implies that basically the sine of y is equal to negative 1 by 2, right? The sine of y is equal to negative 1 by 2. Now, the angles that we know, basically the angles that we are familiar with, if you need a recap of those angles and the trigonometric ratios of some specific angles, then we can basically create a table here. So over here you have basically 30, 60. Over here you can have so basically you have the sine function, you have the cos function, you have the tan function, you have we need to actually do secant and cosecant as well. So you have the cot function, you have the secant function, and you have the cosecant function. And well, of course, knowing these is not necessary in order to create this table, as long as you know the sine of some angles, like for example 0 and for example 30 degrees, and 45 degrees, for example, and 60 degrees, for example, and 90 degrees, and 180 degrees, and 270 degrees, and also 360 degrees. Then you do need to know, basically, to create this table from scratch, you need to know these values. You need to know basically the sine and cos of all of these angles, right? So what that means is that, let me make this table a little bit more. Okay. Okay, so this is the table that you have. So basically I know that the sine of these we have derived before, so I'm not going to spend any time on them on these anymore. I know that the sine of 0 is these are easy to see, meaning that, for example, if you have a unit circle here, and suppose that, let me actually draw a unit circle here and show you how you can derive these. So suppose that you have this unit circle here, and let me actually make a screenshot of this unit circle. And call it basically, let's call it unit circle. On desktop, okay. Now suppose that you have this unit circle and you want to find the sine of, for example, 0 degrees. Now 0 degrees, of course, is the same thing as the same angles in radians would be, of course, 0 radians, and 30 degrees would be pi by 6, meaning that 180 divided by 6 would be 30. And then you have pi by 4 radians, you have pi by 3 radians, you have pi by 2 radians, you have pi radians, you have 3 pi by 2 radians, and you have 2 pi radians, right? Now, I know that basically we said that the sine of an angle is measured across this along any of these vertical axes. Starting from here, you either move up or you move down depending on the angle that you have. Meaning that if your angle is either in the first quadrant or in the second quadrant, then of course you have to move up, because your angle would be, for example, something like this, right? And then the value of the sine of that angle would be this length on the unit circle. This length would be the sine of this angle alpha. So this length on this axis is basically the sine of alpha, right? Whatever that is. Now this is 0, this is positive 1, this is negative 1, right? So that would be something about, for example, 0.7, 0.8 or something like that. If your angle is some angle in the second quadrant, again you have to move up, meaning that your angle is this angle here, call it beta, for example, and then this value on the unit circle, this value from here, from 0 up to there, is the sine of beta. And as you can see in both of these cases, the sine is positive. Now if you have some angle in the third quadrant, you have to measure it across this vertical axis, but down below 0, which is a negative value, which gives you, for example, if you have some angle over here, you have this angle, for example, let's say call it gamma, and you know that basically then you can draw a perpendicular to the vertical axis, and then this value would be basically the sine of gamma, which is of course a negative value. And then if you have, for example, some angle in the fourth quadrant like this, let's call it, for example, I don't know, theta, then you can draw a perpendicular to the vertical axis, and then this value on this length on the vertical axis would be sine of theta, which is again a negative value. That means that if your angle is in the first quadrant, in the second quadrant, the sine of that angle is positive, and if your angle is in the third or fourth quadrant, the sign of that angle is going to be negative. And of course, you can see that if your angle is a zero radian angle or a pi radian angle, 0 degrees or 180 degrees, then of course that length on the vertical axis doesn't exist, meaning that the value of the sine is 0. Meaning that I can say that the sine of 0 degrees is equal to 0. The sine of pi is equal to 0. Also, if your angle is a 90 degree angle, pi by 2, then of course you know that the length on the vertical axis comes all the way up to this point, which means a positive 1. So the sine of pi by 2 becomes a positive 1. The sine of this angle down here, which is 3 pi by 2, you have to come all the way up to this point, which is a negative 1. So 3 pi by 2 would be negative 1. Now 360 degrees is the same as 0 degrees, so you have 0 there. 60 degrees, 30 degrees, 45 degrees. These angles, the sine of these angles you can find based on a simple triangle. Okay, so now in order to basically find these values, what you can do, I actually tried to do a triangle, but my triangle actually did not work. Now, if you want to basically to build that triangle, what you need to do is that, so let's suppose that you have it, hopefully I can draw the triangle here. So let's say that I have this triangle and the angles, the triangle has to be basically 60 60 60 triangle, meaning that an equilateral triangle, right? So you have basically this is 15, 30, 45 and 60. This is 60 degrees and this angle is 15, 30, 45 and 60, and it seems to be it doesn't look right to me, but let's assume that this is a 60 degrees and 60 degrees here. And so since it's an equilateral triangle, all of these sides have the same length. So for the sake of simplicity, I'm going to set basically the side length of the triangle as 1 unit. So if this is 1 unit, then this becomes 1 unit, and this side down here becomes 1 unit as well. Now if I drop a perpendicular to this side, this becomes a 90 degree angle, 90 degree angle, and you know that the perpendicular from any vertex of an equilateral triangle to the opposite side, that is going to be the perpendicular bisector of that side. That means that then this length is equal to this length. Since the whole length is 1 unit, then this becomes 1 divided by 2, and this becomes 1 divided by 2, meaning that this part over here becomes 1 divided by 2 units, and this part over here becomes 1 divided by 2 units. So you have 1 unit here, 1 unit here, and 1/2 unit here, 1/2 unit here. Now you know that since this is basically a right triangle, you know that in a right triangle, hypotenuse squared is equal to the sum of the other two sides squared, which means that I can write 1 squared, this is this hypotenuse, is equal to 1/2 squared plus this side squared, I take it as x, so x squared, which means that x squared is equal to 1 squared is 1 minus 1/2 squared is equal to 1/4. So that is the same thing as 4/4 minus 1/4, which is equal to 3/4. And and so this is x squared, so therefore x is equal to the square root of 3 over 2, right? So this side becomes square root of 3 over 2 units. So then what we have now is a triangle in which and of course when you drop a perpendicular from any vertex in an equilateral triangle to the opposite side, that basically perpendicular becomes the bisector of this angle as well, meaning that this angle is now 30 degrees, and this angle here is also 30 degrees, right? So now you can simply calculate the trigonometric ratios of 60 and 30 based on this triangle, because, for example, the sine of 60 degrees is going to be equal to basically the side which is opposite that angle, which is square root of 3 by 2, is basically the opposite divided by hypotenuse, which is square root of 3 by 2 divided by the hypotenuse. Hypotenuse is 1, is equal to square root of 3 divided by 2. And then you can calculate the sine of, for example, 30 degrees as well in the exact same way. The sine of 30 degrees is equal to the side which is opposite that angle, which is 1/2, divided by the hypotenuse, which is equal to 1, which gives you a 1/2. Which means that the sine of 30 degrees is equal to 1/2, and the sine of 60 degrees is equal to square root of 3 by 2, right? Now let's calculate the cos of these angles as well, because we are going to need them for the next step. So the cos of, for example, 30 degrees, the cos of 30 degrees is basically the side adjacent to that angle, which is this side, not the hypotenuse. Of course, the hypotenuse is always the hypotenuse. But then the side adjacent to that would be square root of 3 by 2. Square root of 3 by 2 divided by the hypotenuse, which is equal to 1, which is square root of 3 by 2. So cos of 30 degrees is equal to square root of 3 by 2. And so the cos of 60 degrees is again the side which is adjacent to that, which is 1/2, divided by the hypotenuse, which is equal to 1, which is equal to 1/2. So the cos of 60 degrees is equal to 1/2. So now the only thing that remains here is basically 45 degrees, right? So we need to calculate the sine and cos of 45 degrees. Now for 45 degrees, we need to draw another triangle here, meaning that we need to somehow draw a triangle in which basically if I draw a triangle here in which, suppose that I draw a triangle, and in this triangle, this angle is, let's say that this angle is 90 degrees, meaning that I have 15, 30, 45, and then 45, 60, 75, and 90. That is a 90 degree angle. And suppose that the two sides have the same length, and this angle is 90 degrees, right? So if this angle is 90 degrees, then this angle, of course, since it's an isosceles triangle, then this angle is going to be equal to this angle, meaning that this is a 45 degree angle, this is a 45 degree angle. 45 plus 45 is 90, 90 plus 90 is equal to 180 degrees, right? Now, if in this triangle, what I can do is that I can drop a perpendicular to this side, and if I say that this side length is 1, this side length is also going to be equal to 1. And now let me figure out how we can actually calculate this. So now this angle over here is actually a 45-degree angle. This is also a 45-degree angle, right? So you have a 45-degree, 45, and a 90-degree angle here. And if I say that this angle is, let me see. Okay, so now let me actually do this again, because now if I say that, now let me actually do the 90-degree angle again. So let's say that this is a well, 15, 30, 45, and then plus 15 is equal to 60, 75, and 90 degrees, right? And then I'm going to draw this side, and then this side is equal to this side. This angle is equal to 90 degrees. If this is 90 degrees, then this angle is equal to 45 degrees. This angle is equal to 45 degrees. And this is an isosceles triangle, right? Now, if I say that, since I know that basically the side lengths are these two sides have the same length, then I can say that if I call this A, for example, this is going to be A as well. And by the Pythagorean theorem, we said that basically the hypotenuse squared, for example, called as x squared is equal to a squared plus a squared, right? A squared plus a squared. That means that x squared is equal to 2 times a squared, which means that x is equal to a times square root of 2, or square root of 2 times a. Now, if I take, so this side becomes square root of 2 times a, this side. Now, if I want to calculate basically, for example, the sine of 45 degrees, so I have to, so this is my hypotenuse, so basically then the side in front of that 45-degree angle is a, and the hypotenuse is square root of 2 times a and a you can cancel out. You'll get 1 over square root of 2, and 1 over square root of 2 you can write it as 1 over square root of 2 and multiply numerator and denominator by square root of 2. You will get square root of 2 over 2. So the sine of 45 degrees is square root of 2 over 2. Now, to calculate the cos of 45 degrees, the cos of 45 degrees is equal to basically, suppose that we're talking about this angle. So I take that side which is adjacent to 45-degree angle, which is a, and divided by the hypotenuse, which is square root of 2 times a. That gives me again 1 over square root of 2, which is ultimately square root of 2 over 2. That means that the cos of 45 degrees is also square root of 2 over 2. Square root of 2 over 2, right? Now, the next thing that we have is let's calculate the cos of these angles as well, and for that I need a unit circle, a temporary unit circle. So basically for 0, which is basically over here, the cos of 0 degrees you have to go all the way up to here, and then for cos we said that we would read the length across this horizontal axis all the way from here 0 to positive 1, and from here all the way up to here, which is -1, right? Now the 0-degree angle would be just an angle on the basically on this line, for which you would have to go all the way up to this point, which is +1. That means that cos of 0 is equal to 1. Now the 360 degrees is also an angle which is right here, so I can write the cos of 360 degrees is also equal to 1. Now for cos of 90 degrees, you can see that this is 90 degrees. So you're not moving to the right, you're not moving to the left, you're right perpendicular to the horizontal axis. Which means that you have you have 0 basically distance on this axis. So that means that cos of 90 degrees is equal to 0. 180 degrees, you have to go all the way up to this end, from here all the way up to here, which is -1, and 270 degrees, again you have to go all the way up to here, which means that you're perpendicular to the horizontal axis, and which means that the distance on the horizontal axis is 0, so cos of 270 degrees is 0. Now from here onwards, it's easy, because for example, you know that tan is the same thing as sine divided by cos. Tan x is equal to sine x divided by cos x. Cot x is the same thing as cos x divided by sine x. And you know that secant x is equal to 1 divided by cos x. And also cosecant x is equal to 1 divided by sine x. Which means that, for example, to calculate the tan of all of these angles, you just take the sine value divided by this cos value. 0 divided by 1 is 0. 1 divided by 2 divided by 3, square root of 3 by 2 is basically, so you have 1/2 divided by square root of 3 by 2, which gives you basically 1 divided by 2 times the reciprocal of this, which is 2 over square root of 3, which is 1 over square root of 3. 1 over square root of 3, you can write it as 1 over square root of 3, and multiply by square root of 3, the numerator and denominator. This becomes a 3, so that is square root of 3 over 3. So tan of 30 degrees is square root of 3 over 3. Now the next thing that we have is tan of 45 degrees, for example. Tan of 45 degrees is the same thing as square root of 2 over 2 divided by square root of 2 over 2, which is equal to 1. And tan of 60 degrees is equal to square root of 3 over 2, square root of 3 over 2 over 1 by 2, which is the same thing as square root of 3 over 2 times the reciprocal of this, which is 2. That gives you square root of 3. So tan of 60 degrees is equal to square root of 3. Tan of 90 degrees, as you can see, it is 1 divided by 0, which is undefined. Tan of 180 degrees is equal to 0 divided by -1, which is equal to 0. And tan of 270 degrees is -1 over 0, which is undefined. Tan of 360 degrees is 0 divided by 1, which is equal to 0. And the next thing that we can calculate is the cot trigonometric function for all of these angles. So cot is the same thing as cos divided by sine, which means that you have to take the value of cos and divide it by sine. So 1 divided by 0 is undefined, which means that the cot of 0 degrees is undefined. Now the cot of 30 degrees is the cot of 30 degrees is basically square root of 3 by 2 and divide that by 1 by 2, right? So that's the same thing as square root of 3 by 2 times 2, which is equal to square root of 3. So the cot of 30 degrees is equal to square root of 3. The cot of basically 45 degrees is cos divided by sine, so square root of 2 by 2 divided by square root of 2 by 2, which is equal to 1. And the cot of basically 60 degrees is 1 divided by 2 divided by square root of 3 by 2. So 1 divided by 2 divided by square root of 3 by 2, which is equal to 1 divided by 2 times 2 over square root of 3. That's 1 over square root of 3, which is square root of 3/3, right? So that is square root of 3/3. Now cot of 90 degrees is 0 divided by 1, which is equal to 0, right? 0 divided by 1 is equal to 0. And negative 1 divided by 0, so cot of 180 degrees is negative 1 over 0, which is undefined. Now cot of basically 270 degrees is 0 divided by negative 1, which is equal to 0. Cot of 360 degrees is 1 divided by 0 is undefined. So that means that cot of 360 degrees is undefined, and also cot of 180 is undefined. And cot of 0 is also undefined, as you can see. Then we can come to secant. So secant of 0 degrees is 1 divided by cos of 0 degrees. 1 divided by 1, or the reciprocal of cos, 1 divided by 1 is equal to 1. Now the cos of, the secant of 0 degrees is equal to 1. Secant of 30 degrees is 1 divided by square root of 3 by 2, which is 2 over square root of 3. So 1 over square root of 3 by 2 is the same thing as 2 over square root of 3, which is the same thing as basically 2 times square root of 3 over square root of 3 times square root of 3. And that gives you 2 square root of 3/3. 2 square root of 3/3. 2 square root of 3/3. So secant of 30 degrees is 2 square root of 3/3. The reciprocal of basically the secant of 45 degrees is 1 over square root of 2 over 2. 1 over square root of 2 over 2, which is the same thing as 2 over square root of 2, which is the same thing as 2 square root of 2 over square root of 2 times square root of 2, which is 2 square root of 2 over 2, which is equal to square root of 2. So the secant of 45 degrees is equal to square root of 2. The secant of 60 degrees is the reciprocal of 1/2, which is equal to 2. So secant 60 degrees is equal to 2. Secant of 90 degrees is the reciprocal of 0, which is undefined. Secant of 90 degrees is undefined. And secant of 180 degrees is equal to -1, because the reciprocal of -1 is -1. Secant of 270 degrees is the reciprocal of 0, which is undefined, right? So basically the secant for the secant 90 and 270 are undefined because at those angles basically the cos is equal to 0, of course. And the secant of 360 degrees is equal to 1. Now going back to basically getting to the cosecant function. The cosecant is the reciprocal of sine, which means that whatever the value of sine of that angle, if you take the reciprocal of that, you will get the value of the cosecant. So cosecant of 0 is the reciprocal of 0, which is undefined. Cosecant of 30 degrees is the reciprocal of 1/2, which is equal to 2. Which means that cosecant of 30 degrees is equal to 2. And the cosecant of 45 degrees is the reciprocal of square root of 2 by 2, which is going to give you square root of 2 ultimately, because the reciprocal of this becomes 2 over square root of 2, which is the same thing as 2 square root of 2 over basically square root of 2 square root of 2, which is 2 square root of 2 over 2, and that is equal to square root of 2. So the secant of 45 degrees is equal to, the cosecant of 45 degrees is equal to square root of 2. And the cosecant of 60 degrees is the reciprocal of 2, the reciprocal of square root of 3 by 2, which is 2 over square root of 3, which is the same thing as 2 square root of 3 over square root of 3 times square root of 3, which is equal to 2 square root of 3 thirds. 2 square root of 3 thirds. And that's cosecant of 90 degrees is the reciprocal of 1, which is equal to 1. The cosecant of 180 degrees, the reciprocal of 0, which is undefined. And the cosecant of basically 270 degrees is the reciprocal of -1, which is -1. And the cosecant of 360 degrees is the reciprocal of 0, which is undefined. Right? So this way we have a table that we can use at least for all of these exercises. So I will make a screenshot of this table and then we will get back to our exercises. Okay, so now basically what we wanted to do was that we wanted to calculate the principal value of sine inverse of -1/2. So we set that basically the sine inverse of -1/2, we set that equal to y, which means that basically the sine of y is equal to -1/2. So -1/2 -1/2. Now basically here you need to find out some way to use basically what we found here. What we found here in this table, for example, you can see that basically the sine, you need to know the sine of what angle is some number that has the same absolute value as this number, as this ratio. So the absolute value of this ratio is 1/2 basically, right? Ignoring the sine, it's going to be 1/2, and it's the same thing as the sine of 30 degrees, right? So then based on the angle 30 degrees, you can find a way in order to figure out what sort of angle there is in the unit circle whose sine is -1/2 and not +1/2. So I know that the sine of 30 degrees is equal to 1/2. But this angle, whatever it is that I have here, the sine of that angle is -1/2. So if I draw a unit circle here, and let me draw the unit circle here. If I draw a unit circle here, so I know that basically this angle 30 degrees is the sine of this angle is 30 degrees, and the sine of this angle is 1/2. That means that basically you can see that even if you basically go over this, if you go over this on the vertical axis, you can see that you go exactly halfway between 0 and 1, which is equal to 1/2, right? Now, what that means is that now the angles, the possible angles that in the unit circle that could have the same sort of trigonometric ratio for sine is basically if I drew an angle over here, and if I come 30 degrees over here, if this angle is 30 degrees, if this angle is, let me do this properly. So let's suppose that you have this, let me make this smaller so that we can actually do something with this. Okay, so it doesn't really have to be okay. Now I think we can, or I could even go up here and come down here. Okay, now if I go and choose if I drew a unit circle over here, border and 1 pixel, and so if I do this unit circle here, you can see that if I have a 30-degree angle here, the sine of this angle is going to be equal to 1/2, and this is basically 30 degrees, right? Now if I draw some angle over here, meaning that, for example, I could imagine that I could have some angle over here, something like this, and this angle would be this angle between these two lines would be 30 degrees, and so the whole angle, this whole angle starting from here all the way up to here would be 150 degrees, right? 150 degrees, and then the sine of that angle is going to be exactly the same value. So then I can say that the sine of 150 degrees is also equal to the sine of 30 degrees, which is equal to 1/2, right? Now what I'm looking for is the sine of some angle. I'm looking for some angle whose sine is not positive 1/2 but negative 1/2. That means that I could probably draw some angle over here in such a way that this angle becomes 30 degrees, and so as a result the whole angle starting from here all the way up to here becomes 330 degrees, right? And as a result the sine of the angle would be halfway between 0 and -1, which I could say that then the sine of basically 330 degrees is equal to -1/2, right? That I could do. What I could also do is that draw some angle over here in such a way that this angle is 30 degrees, and as a result this whole angle here becomes 210 degrees. That is 210 degrees, and so the value of the sine of this angle is going to be exactly the same value, and so I could say that the sine of 210 degrees is equal to -1/2. So one of these two angles, meaning that I could say that, for example, over here y is equal to 210 degrees, or basically y is equal to 330 degrees, right? Now, but the problem here is that the range of this function, this y, has to be in the range of this function, in the range of the sine inverse function. And when we talked about the sine inverse function, we said that we had this somewhere over here. Let me find it. We said that basically the range of the function goes from negative pi by 2 to pi by 2, and the domain goes from negative 1 to 1. So that means that you can go from negative pi by 2 to pi by 2 for the sine inverse function, which means that this angle over here, 210 degrees, although it's a solution here, but I cannot use it because it's outside the range of the sine inverse function. So the angle that I can take is actually 330 degrees, right? Which means that and 330 degrees is the same thing as 330, and in degrees is the same thing as, now there is a conversion factor that I'm going to again calculate here, and then we will take a screenshot because I don't want to do the same things over and over again. So we said that basically pi radians is equal to 180 degrees, right? So that means that if I divide both sides of this equation by pi divided by pi in radians is equal to 180 divided by pi in degrees. That means that 1 radian is equal to 180 divided by pi in degrees. That is one thing. And the next thing that we can do is that we can take the same equation and divide both sides by 180. Meaning that I can write pi divided by 180 in radians is equal to 180 divided by 180 in degrees, which gives me pi divided by 180 radians is the same thing as 1 degrees or 1 degree. So I can use, whenever you want to basically convert between radians and degrees, you can use this formula. So let me make a screenshot here. And I'm going to call it, for example, radian degree conversion, right? On desktop, and save it there. So what that means is that if I want to convert this angle into radians, so I know that 1 degree is the same thing as pi over 180 radians. That means that 330 is the same thing as 330 times pi divided by 180 in radians, and 33, 18, and divide by 3 you will get 11, divide by 3 you will get 6, 11 pi by 6, 11 pi by 6 radians. 11 pi by 6. Now 11 pi by 6 is the same thing as basically, of course, 330 degrees, which is of course outside the range of this function. That is also a point to be noted. So now I have calculated the angle, and it has become, since it's 330 degrees, it is actually outside the range of this sine inverse function, because we said that the range of the function goes from negative pi by 2 to pi by 2. That means that you can basically move from negative pi by 2 to pi by 2. That means that I have to express this angle as a negative angle, and the angle would be negative, basically, that is negative 30 degrees, which is negative pi by 6, right? So I express the angle, the same angle as basically y is equal to negative pi by 6, which is ultimately the same angle, of course. But in the context of this, function, you have to express it that way, otherwise it wouldn't fit into that function. So now, in order to write down the whole solution that we have, so we said that basically we wanted to calculate the sine inverse of negative pi by negative 1 by 2. So you can say that let the sine inverse of negative 1 by 2 be equal to y. Then you can say that the sine of y is equal to negative 1 by 2, which is equal to the negative of sine of pi by 6. Negative of sine of pi by 6. Now you know that the negative of sine of pi by 6 is of course equal to the sine of negative pi by 6, right? Because we have actually argued before that actually if we knew this from the very beginning, we wouldn't have to go through the whole unit circle and the whole business of unit circle. But well, we said that the sine of negative x, is equal to negative sine x. We said that the cos of negative x is equal to cos x. We said that the tan of negative x is equal to negative tan x. We said that the cot of negative x is equal to negative cot x. We said that the secant of negative x is equal to secant x. So these two are, in that respect, are alike. And we said that the cosecant of negative x is equal to negative cosecant of x, right? And based on this, you can, when you have the negative of sine of pi by 6, you can simply write it as sine of negative pi by 6. And so what that means is that sine of y is equal to sine of negative pi by 6. Therefore, y is equal to negative pi by 6. So of course I can add a few sentences here. So I can write that we know that the range of the principal value branch of sine inverse is, we know that basically the range of the principal value branch, the range of the principal value branch of sine inverse is basically negative pi by 2, as we saw earlier, to pi by 2, and sine of negative pi by 6 is equal to negative 1 by 2, right? Therefore, the principal value of sine inverse negative 1 by 2 is equal to negative pi by 6. Negative pi by 6. Okay. So that is your solution. Now it seems that it took us a whole video to go through this. Now I'm going to end this video here, and in the next video we will continue these exercises. I'll see you in the next video.